What if I told you that your 50th message is going to cost you 50 times more than your very first message? Hey everyone, today I'm going to show you something that's costing thousands of dollars to the developers. And you know what? They don't even realize it. If you are building AI agents using the Microsoft Agent Framework or any other framework, you need to make sure to watch this video till the end so that you know how to save 50% of your API costs using very simple tricks. So what are we waiting for? So this is what we are going to teach in this video. So please stay tuned till the end of the video and make sure subscribe to the channel so that you'll get all the important information around this AI agent and AI application development. So without any further ado, let us get started with our recap what we have done in our very last video. In our last video, we have seen how to create an AI agent using the Microsoft Agent Framework, and also we have seen how to add the memory to the AI agent since it is stateless to make sure the AI agent knows the conversation what is happening around. At the same time, we also find that as the conversation continues, the number of tokens that we are passing as an input token is keep increasing, but the output is maybe a smaller one or bigger one. But what that means to you is as the number of input token increases, the amount that you are paying for the API cost increases, and also the amount of time it took to process and give you the response also increases. So this is what we are going to solve in this video. So this is what we call it as a snowball effect. That means slowly increases your input token limit and which will affect your total API cost, also the performance. By now, I hope you understand what is the need of reducing the number of input tokens that is being injected to the LLMs to get a response. And in this video, I'll show you which is not there in the Microsoft Agent Framework out of the box for the Python developers. Now, let us talk about the four important strategies that you can think of. Now, very first technique is sliding window based. That means you'll always keep a very large n number of messages along with your new question as a context to the LLM. If you understand it correctly, you are removing the certain number of messages after that limit. That means the context will be removed to the LLM. So sometimes LLM may start hallucinating because it doesn't know what happened before that when the ear is pointing about it, right? So this is one of the con. You need to choose it carefully, depends on the requirement. Then the other one is token-based truncation, where this is more or less similar to the sliding window-based approach, but instead of a certain number of messages all the times, we will go with a token limitation. That means depends on the model that you are using. You might need to make sure how many number of input token you can send it, right? So you have to set the threshold value and keep truncating the messages which is going beyond the token limit. This, now let us talk about the third one, which is summary based context. This is what we have implemented, and you'll be seeing that a little later. So the main idea of this one is we have to have a certain threshold, similar to the last time, maybe 10th messages or 11th messages. When the number of messages count hit that, we are going to summarize everything what happened before. We are going to extract like the key topics, insights, and the names, everything. Then we are going to remove the all the summarized messages and replace with a single summary message, which will be very small. So this is a very efficient one compared to the other two things where the number of input token is going to be minimal all the times. So we are kind of making a better choice here, right? And the fourth one is something like a rack based approach where we are going to use a vector stores as a data store for the context. We'll be keep storing all the information in the vector stores as a nodes or topic wise or sections or hierarchies. And when we are making a question to the LLM, there will be a certain logic that is going to get the relevant topic that is regarding to this question might be suitable from the vector store and combine them and send it to the LLM. This is what the approach is. It has its own con, but if you implement it in the right way, it will give you a really good benefit out of it. Okay, but the For the small use cases, it is like over engineering. You might not need that. So far, we have learned about four new techniques how to reduce the number of input tokens that can help you reduce your API costs. As I mentioned, I have implemented something that is not available out of the box from the Azure framework using the abstraction that they have provided. So in this code, I'm going to show you the comparison with and without these techniques, how much cost that is happening on the API level, right? Okay, cool. Now let us see the code. Now, for you guys, I have prepared one notebook. Maybe you can later download and see this whenever you want. And if you want to implement your own implementation, take a reference from this and do your own. So, in this notebook, what we have done is, if you have already followed me in our last video, I just set up the environment variables and the agent framework. And also, I just use the plotly just for the visualization. And in this example, I'm going to use two different models, one for the reasoning and one for the summarization part, because I just want to show you the real value. Okay. And each one has their own cost or token. So I just kept it over there. Then this method is not what we are looking for. You can go through this notebook and you can find it how we are doing the display of the visuals. This is our agent, what we have done in our last video, right? So after that, what we have done is I created around 50 questions, very small questions, mostly around that Python only. I created this. My idea is we will run through this all these 50 questions. We will capture the input tokens, output tokens, and we will calculate the cost for that entire operation as a cumulative length. Then we will do the same thing with the other approach using the summarization. Then we will compare what is the value that you are saving, right? Without losing the quality of the response. So these are 50 questions that I have prepared. Then I'm running through. So as part of this, I'm not much worried about the response because already I have seen that, but I'll just show you how it is happening. Okay. Each interaction, suppose if you see the very first interaction, the input token count is just 55 because I just asked the question and it gave the response, right? Then in the second question, if you see the input token has increased because it will take the first question, first response, and then the second question together as an input token. That is what is happening here. And as it and on 15th interaction, if you see that input token count has increased to 4,000 tokens and the output token is just 33. That means every consecutive message is going to accumulate all the context what is happening before. So that is the main problem that we wanted to solve. And this is the small visualization that you can see. Each interaction level, the number of tokens are keep increasing, right? So if you see the cost, for all the 50 questions, we got this much of cost in total. Okay. Now, this is what exactly what we wanted to solve using our chart reducing techniques. What I used is I used the summarization approach where I have put a max interactions as a 10. After every 10th, it is going to summarize that last 10 messages, remove them, and just use that extraction of the content and keep only the one message instead of the 10. That is what we have done. So for that, there is a certain abstraction that agent framework has given to us. This is the one of the abstraction that we need to implement to do that. So I have used this protocol and I have implemented on top of that where there is some contextualization and then list messages what is going to be used by the agent and just everything. Okay. So what I have done is whenever that reaches to this max number of counts, I'm going to trigger the summarization and reduce the number of messages in the list. So this is some code, some pretty code. Maybe please go through this and share your feedback to me. So what basically we have done in this method is the moment it triggers that threshold, it is going to take all those messages, summarize them, and remove those messages and append this one as a very first message, right? And it will keep happen after every certain period, right? Then what I have done is I just created one more agent to summarize. How to summarize? What are the key things to be extracted? So for this example, it is very simple, but depends on the use case. You might need to write some very well structured prompt for this, right? So what I have done is I created an agent, but this time I'm passing the chat as a story with our custom implementation, right? Then I'm just running through the same question again, but this time if you see on high level, the first interaction is same, second interaction it keep increases. The reason is we are not doing the summarization every time, but we are doing after certain limitation, right? So okay, the summary will trigger and it will change everything. Then the number of input token become less. So it will keep going like that. Then if you see the plots, it's very different. So every 10 messages, it is increasing, but again, the summary is become almost half of it. So it's doing like that. Okay. And when you see the overall tokens at the end, it just actually half of the tokens, almost. If you remember, the input tokens in our first approach is nearly 4,000 change. Now it is just 1,500. Just imagine scale how much you can save. Or if you understand the number of tokens, the input has dramatically reduced nearly 40 to 50%. Right? Now I have written this code just to write down the comparison of these two approaches so that we know better this thing. Now, if you observe this, the red one is done without the summation technique. The green one is with the summation technique. It's a huge difference. That means at a scale, when you are deploying to the billions of users, when they are using your application, just imagine what is the amount of cost that you are going to save without losing the quality of the response. As a developer, by now you will have some question that, hey man, we are using a LLM again to summarize and every 10th interaction, right? It is going to add you additional overhead on the cost. Absolutely. So that is where the technique comes. You need to use a very small model just for the summarization. You don't need a very big one to do a small job. So the summarization things and all, even GPT-5 Mini can do a better job. So if you see the blue line here, that is what the summarization also. I mean, the actual input plus summary level input details, everything together, still it is very less, right? After 50th interaction. So that is what we are going to save here, nearly 50%. If you implemented it even better, you can achieve even better results out of this. Cool. So I hope you like the video so far. Now we just realized that how much amount of money that we can save on our API cost by just following this very small techniques, right? I hope you like the video so far, and if you really like the efforts that I'm putting to make these videos, please do share, like, and subscribe this channel so that you will not miss out this sort of content that which you will not find anywhere else, right?